morning, everybody. I wanted to do Unit 10, Lesson 5 with you because it's a little bit tricky when we start getting into some scenarios of probabilities where we have to know what's given. I'll get into it in a minute, but make sure you're turned to two-way frequency tables, which is Unit 10, Lesson 5, and we're going to begin. Just so you know, I teach AP Stats. It's a course that all of you will be eligible to take senior year. It's an AP course, obviously. It's relatively easy. I think most students start having difficulty in their third quarter, so the first two quarters are very solid for most students. And stats is one of the courses that almost all of the college majors require, whether you're going into political science, psychology, teaching, obviously medicine, obviously business, engineering. There's reasons why we all need to know statistics. And the frequency tables are kind of a big deal because it's the beginning of probability. It's the middle of probability. You'll do more probability in junior year in Algebra 2. So what they start off with is that we're supposed to poll the class, and obviously I can't poll the class, but we're supposed to do our own frequency tables. So let me just go through what they're saying in the last box. Survey data contains one category is interesting, and that's probably what you did in middle school or even grade school, made bar charts. How many people in the class have a dog? How many people in the class have a cat? Or you might say, how many of you have one car? How many of you have two cars? How many of you have three or more cars? And you tally it up, right? It's also very interesting in many cases to see the probabilities on not only one category, but a second category. For example, they're mentioning a person's gender and their profession. You know, we don't see a whole lot, unfortunately, of women in engineering, but we're certainly seeing a lot more women recently in politics, for example. So if I'd asked that question 40 years ago, there'd be less women in politics. Now there's more. So knowing it by gender, by age, by political view are ways in which people use frequency tables often. So this is nice and easy. Color of their eyes. They might go further and do color of hair. So let's go to this. So in exercise 2, they have a generic class of 20 students, and they recorded their hair color and eye color, which is shown in the two-way frequency table below. They only have 3 colors of hair: black, blonde, or red. I know there's more, but those are the 3 colors they chose. That's that. Eye color, they had blue, brown, green. Again, I know there's more: hazel. Some people even have gray eyes, and a few people have black eyes, right? So let's go through this and let's really dissect what the question is asking, because it's most important what the question is asking and being able to look at it. It's not always clear cut, and that's why I wanted to be on the phone with you, on the video with you today, to be able to do this. First question, how many students had blonde hair and blue eyes? Okay, so this one, since we have numbers in front of us, all we need to do is look and see how many students had blonde hair. Here's blonde hair, and blue eyes, and where they cross. And that number is right here, which is 4. So there are 4 students that had blonde hair and blue eyes. Second question, how many students had red hair? So the red hair portion, I'm going to be looking only at red, but the entire list. So that, again, happens to be 4. Okay, so depending on what it's asking, the first question was asking 2 questions, blonde and blue. And the and is important, so it means we're going inside. We're going to be going into what's called the joint, right? The joints. Think about a joint like an elbow is a joint. It connects 2 things. It's between 2 things. And then the one on the right is marginal. We're looking down, got it, to the margins. Okay, and it's only doing one category versus 2. So let's do what's asking here, which is construct a table that shows the joint frequencies and marginal frequencies for the data shown below. Okay, so what I want to do is, the reason why I was bringing this over is I wanted to see this. When we talk about joint is going to be inside. So I will draw it and then I'll erase it. The joint relative frequencies are going to be everything here in the middle. Okay, That's the joint. Again, think about a joint between the elbow or in your knee or wherever else you think of joints. Marginal is going to be, as we know it from English class, the margins. So the marginal frequencies are going to be on the outside. In this particular question, there's really not much we have to worry about as far as joint and marginal, because really we're going to be doing the same math for both of them. But they want us to fill in the joint first, and then we want to do the marginal. So easy enough. This isn't actually not hard at all. What we're going to do is we're going to take our numbers that we have on the top. So I have my totals, and we're going to do the math. All we have to do is we have to take each number and divide it into the total number in the survey. So for example, there were 3 people who had black and blue. So I'm going to put a 3 there, divided by 20. Now I wish this was bigger, and maybe I do need to make it bigger. Why don't I do that right now? Because I want to show you guys, because you guys have really small pens and I have a really fat finger. So I can't get it as tight as I want to, but I want to. So give me 1 second. I'm going to do this. I'm going to try and make it bigger for you guys. So give me 1 second. I don't know if it's going to get bigger. It's a little bigger. Okay. So I will do this. I will come over here and I'll make it just as big as I can. I don't know how much more I can make it bigger. Okay. Okay, that's pretty much bigger. Okay, fine. But now, of course, I don't know my numbers. So give me 1 second. Let me do that. So you guys can follow along. And I'm just going to kind of go through it with you real quick and just get it over. Okay, there we go. Fine. So this one was going to be 3 divided by 20. What's 3 divided by 20? We're going to do the math. 3 divided by 20, I'm going to make it as a decimal, is 0.15. Okay, let's do the next one. We'll go straight down. I'll do all the blacks first. Black hair, brown eyes, 5 over 20, which is going to be 0.25. We know that one, right? 1/4. 1 over 20. We would do that, and we get 0.05. So 9 over 12, we might as well do all the joints first. Let's do all the joints. So go ahead and keep on going along. The next one was 4 divided by 20. Okay, 4 divided by 20 is 1/5, which is 0.2. 0.20. 2 divided by 20 is 0.1. And again, we have 1 divided by 20, which is 0.05. All these, by the way, should equal to 100 when we get right down to it. When we add up all the decimals, they should equal 100, unless you're rounding, and then you might have some rounding problems. 1 over 20, we know is 0.05. 0 over 20 is just plain old 0. There's no one that had brown eyes and red hair in the class. Of course, we know that can happen. And 3 over 20 is, again, 0.15. Okay, so those are all the conditional frequencies. Why is it important to know that? Well, it's important because if I asked you what's the probability of someone in the class having black hair and blue eyes, you'd say it's 15%. Okay, fine, good, right? So you would actually quickly be able to go and get to that number, or you just do the math. Rarely do we have to do the math on the entire joint relative frequency for the entire table, but obviously if it asks for it, you do it. Usually it's going to be one-offs, and I'm going to get to that to the next example. Let's do the marginal relative frequencies. Why is it called something different? Because we're going to use them in different ways eventually, but it's the same math. So for example, I'm going to do the totals for everyone who has blue eyes. So I'm going to do 8 divided by 20. So 8 divided by 20, I don't know off the top of my head, is 0.4. Well, I did if I thought about it for a second, right? 40%. So I can either keep it as 8 over 20, but I don't know, again, off the top of my head, what 8 over 20 is. I like to make it sometimes a decimal. You don't always have to make it a decimal. You can leave it as a fraction, and that's fine too. It depends on what the question's asking. 7 divided by 20. 7 divided by 20 is 0.35. And 5 divided by 20 we've already done, which is 0.25. Let's go down and do the bottom. 9 divided by 20. 9 divided by 20 is 0.45. 7 divided by 20 we just did, which is 0.35. And 4 divided by 20 is 0.2. Okay, and if I added all these up, for for example, I'll add up all of the eye colors. 0.4 plus 0.35 plus 0.25 is, of course, 1, because 20 divided by 20 is 1. Okay? So that's how we do joint relative frequencies. Joint is going to be in the middle. It's going to be the joints, and marginal relative frequencies on the outside. Okay? So let's move along, and let's go to now questions associated with it. And this is where it gets trickier, okay? So I want everyone to definitely pay attention. Let's see if there's a connection between eye color and hair color by using conditional relative frequencies. We did joint relative frequencies and marginal relative frequencies. I'm now doing conditional relative frequencies. Sometimes the wording on it is super helpful because it'll help you zone in on what you need to do. Let's go through this. Same data. What is the conditional relative frequency of having green eyes if you have red hair? This is the equivalent of asking what percentage of people have red hair, with red hair, have green eyes. Okay, so here's the thing. It's saying what's the conditional relative frequency of having green eyes if you have red hair. So the given is having red hair. And I wish you could see me because I'm moving my hands around, pointing out the given. So here's how it works. When we have this given, the given is always going to go in the denominator. Okay, and the both is going to go in the numerator. Let me explain what I'm talking about here. It says given, so it doesn't say given, it says the conditional relative frequency of having green eyes if you have red hair. The given is having red hair. So what I'm going to first do is I'm going to go straight down to having red hair, which is 4, right? So I'm going to write given 4. Given there's 4 people in the classroom that have red hair, what's the probability they have green eyes? Well, I'm not going to go to the green over here. That's not what I'm going to do. Because what I'm looking for is green eyes with red hair. That means both, right? So I'm going to go to green eyes and red hair, which is right here, which is 3. So the conditional relative frequency of having green eyes with red hair, having green eyes if you have red hair, sorry, the word if is super important, is 0.75. Okay? Let's look at the next question. You'll see that it's a little different. It's really kind of like subtle, very subtle. What is the conditional relative frequency of having green eyes if you have black hair? Okay, well, we just did one like this, so let's see if we can do this. Green eyes if you have black hair. So the if is the given. Black hair, let me make the color black so we'll see that. Black hair is 9. That's my given. Now I'm going to go to green eyes and black hair, which is right here, which is 1. And that equals 0.111111, right? Does it appear that having green eyes has a dependency or at least an association with having red hair? Explain. So here's how it is in statistics. If you have data that is not equal, there is probably a dependency. And certainly with these two data, we can completely see that we have 2 groups of people that had green eyes, but there's a probability of having red hair, 75%, versus only having black hair, 11%. So is there a dependency? Yes, because 0.75 is not equal to 0.11 seems to be dependency. That's all we have to write. I don't have to really get into the fact that, well, we kind of know that people who have red hair usually have light eyes, because not always, but that's usually the case. People who have black hair normally have darker eyes, but that's not always the case. But we certainly know more people who have lighter hair, red or blonde, that have lighter eyes than we know people who have dark hair with lighter eyes, right? Okay, so is it more likely that a person with black hair has blue eyes or a person with blonde hair has brown eyes? Use conditional frequencies to support your answer. So let's do this one together. Maybe you can try and think about what the numbers might be. So is it more likely that a person with black hair has blue eyes? So let's do that one. So we're going to do the black hair. So we're going to do the black hair with blue first, okay? Okay. Is it a person with black hair has blue eyes? Now this is flip-flopped. I'm actually saying that I want to know that if you have black hair, what's the likelihood that you're going to have blue eyes? So the black in this case is the given. So I'm going to go, let me erase some of this stuff that I have going on up here. I'm going to go to the black, which is black hair, which is down here, 9. And I'm going to then jump up and say, okay, what's the probability they have blue eyes, which is 3. Okay. So given they have black hair, 9, what's the probability they have black hair and blue eyes? 3. So we'll get to the number of 0.33. And again, you don't have to make it into a decimal, though you might not know off the top of your head whether a fraction is bigger or smaller than another. Let's go to the other question now. What's the probability that a person with blonde hair has brown eyes? So let's go to that. So now we're looking for blonde hair and brown eyes. Okay. Okay, so let's do that one. So blonde hair, let me use a different color. Blonde hair is 7. So given they have blonde hair, what's the likelihood that they have brown eyes? And that number is, if they have blonde hair, they have a 2. So 2 divided by 7 is 0.28. 285, which is really 286, okay? So is it more likely a person with black hair has blue eyes or a person with blonde hair has blonde eyes? Use this support, AKA justify your answer with math. So obviously, yes, black with blue is greater than blonde with brown. And because I already have my numbers up top, 0.33, and if you want, you can write that 0.33 is greater than 0.286. Okay? I know it's a little subtle. It's very subtle. You have to read each question, which is why you start getting into this whole idea that math at times is actually English class, especially when you start getting into wordy type topics. Let's do the last question and we'll be done. So a survey of 52 graduating seniors conducted to determine if there's a connection between the gender of a student and whether they're going to college. Based on this data, what's more likely? Someone going to college is female, this is our question, or that someone who is female is going to college? What? Isn't that the same question? It's not the same question, so let's break this down. So the first thing you want to know is that someone is going to college is female. So the first thing is someone is going to college is female. Okay. So the given here, think about it for a minute, is going to college. So I'm going to write it like that. So I'm going to say college is my given. And what's going to be on top? Female, the way we say it in probability is a upside down U, means and, female and college. Okay, so I'm going to do that math right now. So the probability of going to college is 29, and the probability of female and going to college is 13. Okay, and I want to do the math real quick because I'm sure I'm going to need to know what number is bigger, and that's going to be 0.448. Okay, let's do the next one. I'll use a different color. Someone who is female is going to college. In this case, the female is in the denominator. That is the given. Female is going to college. So I'm going to say college and female. So let's do that one. So female, let me erase this. Female is 22. And going to college is 13 in female. So 13 divided by 22, well, we already know because that number's going to be bigger, is 0.59. So is it more, and I got to answer the question, it's more likely, and I can write at this point, more likely. And I'm going to point right here, just not have to rewrite it, where it's female going to college. And how do I want to confirm that? I'm just going to show, I just opened up something. 0.59 is greater than 0.448. Okay, so what's our homework going to be for tonight? I created a worksheet using the Yanni and Laurel information, and I just want you to answer I think I have a total of 5 questions on there. Most of them are similar to the ones we've just done. I want to see whether this is a topic that made sense to you. It's also kind of fun to see how our classes, I put the 2 classes together. Not everyone answered, but I had most people answer. I had over 2/3 answer the question. So thank you for doing that so quickly. And you have a wonderful day and good luck with your homework. Have a great one, everybody. I miss you. Bye now.